We're not doing quizzes. We're doing this. So what did you match up your function a with? The negative x minus 2 squared. What you got? D. Good. Where do we match up function b with? Graph C. Okay. Function C. What you got? Graph A. Nice. Function D. Graph F. Function E. Graph B. And then function F goes with graph E. Nice. All right, so what gave away A, C, and D? How are they different? The graphs, A, C, D. Not C. Hold on. I'm losing it. Graphs A, D, and E. There we go. They're all reflecting, right? And what was in all of their equations? I heard it. A negative, right? A negative made it reflect. Good. The 2 is what's going to make it skinnier. So they all show different characteristics. Okay, they're all written. These are all quadratic equations, and they're written in vertex form. Okay, tomorrow we're going to talk more about vertex form and standard form. But looking at the vertex form of these quadratics, they're all written in A times x minus h squared plus k. So that should be familiar with like what you said yesterday on your test. Okay. What does A do to the graph? What did it do? So this guy, this guy, this guy. What is it?
Stretch or shrink.
Okay, so it's a stretch or shrink. What else did it do? What if it was a negative? What'd you do? Yeah, it was a flip or a reflection. Okay. Both with our y values, right? This was a vertical stretch or shrink, and this was a reflection across the x-axis. All right, how about the x minus h? What does the h do? What does it always do? Moves it side to side. Yeah, so it moved left or right. And then our k, if we added something on the end, what did that do? Lila. It is the vertex. Yes. Serena, what does the k do? It moves it up and it moves it down. Yeah, so then HK gives you the new vertex once it gets moved. Okay, so these are all quadratic functions. That's what we're going to focus on for this entire chapter. It's all about quadratics, meaning we have an exponent of 2 on everything that we're doing with. Okay, last unit focused more on lines and absolute values. Okay, so now we're moving to the quadratic. So it has some similar characteristics to an absolute value, which we'll talk more detailed about tomorrow with like reflections and vertex and that kind of movement. What is the graph called though? It's not a V. It's a U shape that's called a what? A parabola. If you're in English class, it's called a parabola. If you're in algebra, it's a parabola. All right, so this whole chapter is focused on just these functions, okay, and these functions alone. Now, what is nice about transformations, which are like, there's nothing nice about transformations. They are the same no matter what the function is, okay? So these are the transformations you just tested on yesterday. So the exact same things. Everything on the left-hand side is showing vertical stuff, so up, down, reflecting up and down, being stretched up and down. And then on the right side is all of your horizontal stuff. So being shifted left to right, reflected left to right, or being stretched out left and right. Okay? So it's showing you how it looks when it's being applied to a quadratic function. So being moved up something is going to be x squared plus a number. Okay? Being shifted left or right, I'm going to have x minus h in parentheses and then a square on the outside. All right, so this is a nice little cheat sheet that we can come back and reference to throughout our lessons. Okay, remember a big thing with our negatives, if we are putting a negative out front of my function, that negative is not part of my x, meaning it's not in parentheses. So negative x squared, the negative stays out. Okay, but if we're reflecting across the y-axis, which is when we reflect left to right, that means my x gets the negative. So when your x gets the negative and you have to square it, that changes back into a positive. So this is something that we just need to keep in mind. Okay, where is the negative? Is it attached to the x or is it attached to the entire thing? Because that'll tell you if it gets squared or if it doesn't get squared. Yeah? Okay, here we go. You want to start simple? Let's start simple. Describe the transformation of x squared represented by g of x equals x plus 4 squared minus 1. Then we're going to graph. So seeing x plus 4 squared minus 1 told me what happened. It went left 4. Good. So the x plus 4 squared shows me left 4. And the minus 1 shows me down 1. We're going to graph these. So it started off as x squared, which is my parent function. So we know that that starts at the origin. If I plug in 1, 1 squared is 1, so 1, 1. If I plug in 2, 2 squared is 4, so that's my next point. And then reflect on the other side. We did this a little bit in our last chapter. But now let's need to transform it. So how did the whole thing go? It all went left 4 and down 1. So take my vertex, left 4, down 1. There's my new vertex. Okay, each point goes left 4, down 1. 1, 2, 3, 4, down 1. Oops. Like that. Yeah? Is that okay? That's coming from your parent function. Excuse me. Our next one, we're going to use our calculator to help us out. Because our next one, it's not really just left, right, up, down. Now we're multiplying by stuff, right? So it gets a little tricky. Could you do it by hand? Absolutely. But why? Right? That's not what the Algebra 2 skill is. The Algebra 2 skill is, do you know the transformation? Okay, and can you graph it? Not can you plug in points to make a function. All right, so example 2, we are still coming from our parent function of x squared. So I'm going to go ahead and just draw that parent function on both of these. 1, 2 is 4. Same with this. 2, 4, 2, 4. All right, part A has been transformed, and it shows me by negative 1/2 x squared. So remember, the negative is something, and the 1/2 is something else. What is the negative on its own? A reflection across what? Reflect over x. And then the 1/2 is showing me what? It's not in parentheses, so it's out front of the whole thing. A vertical shrink. Good. By 1/2. So I know it's going to be flipped upside down, and a vertical shrink means it's going to get wider. Okay? I could plug them numbers in, But I want to show you how to use a calculator, so let's get those out. So calculators, we're going to go to y equals, and we're going to graph both of these functions. So y equals x squared is your parent function. Your square button is up here across diagonal from the 7. And then underneath that, I'm going to graph the new one. I'm going to make it pink. The what? So X is the button next to alpha.
Okay.
And then squared. Now I'm going to do negative 1/2 x squared. So here's my negative. Whenever I do fractions, I always put them in parentheses just to play it safe. So I'm going to do parentheses 1 divided by 2 parentheses x squared. So it doesn't matter where you have it. It's on 2 different lines. If you have a color calculator, you can pick your color. Okay. Once you have this, I want you to push graph. You have to do 1 divided by 2. Yes. All right, push graph. And I have a feeling because of the last problem I did with my last class, your window does not look like mine. Right? Is your window kind of whack? A little bit? If your window is out of whack and you need to go back to 10 by 10, push zoom, the top middle button, push zoom, and then the number 6. And it'll bring you back to a 10 by 10, and then it'll look like mine. Zoom 6 always fixes your window.
Do I click on 6?
You can click on it or you can just push the number. Either way. And it'll fix your window. Takes it back to the standard 10 by 10, and you should look like me. Push graph. Anybody not seeing what's up here? Okay. Did your graph reflect? Is it wider?
Yes.
Yes. So we need to plot points. Zoom 6.
Here we go.
Zoom 6. So let's figure out some points to plot by looking at the table. Look at your calculator. So look at the graph button. Doesn't it say table right above it? And it's in blue writing. So push the blue button. And then push that, and now we have the tables. Those blue numbers are my parent function. The pink numbers are the transformation. So I can look at any x value I want, and let's plot some of those points. So second graph brought me to the table. You can move your arrows to see different x values. What are your x values? Are they doing all the way on the, is it 0, 1, 2, 3? Okay. All right, so let's plot some of these. So what is that? -2, -2 was a point. -1 and -0.5. 0, 0 is still my vertex. 1.5, 2, -2. I think 3 and like 4.5 was a point. Is that right? 3, -4.5. And here is our parabola, like that. There you go. There you go. So those are the ones we're trying to plot. We good? Because we're going to do it again. All right, we're going to do the exact same thing. A new function now is going to be in parentheses 2x being squared plus 1. So what can we expect to happen? What transformations just happened? In my next one, so 2x inside of my parentheses shows me a horizontal. You have that cheat sheet on the front. Your a value is bigger than 1 inside of your parentheses. Should be a shrink by a factor of 1/2. Good. And then what's that plus 1 doing on the end? It's moving up 1. So a horizontal shrink, visually, it's going to squish it from the sides. So I can visualize my U shape getting smaller together. And the whole thing's going to be lifted up 1. All right, go to your y equals. You want to keep x squared, right? Keep that, but change your other function to parentheses 2x parentheses squared plus 1. So go back to y equals. I want to keep my parent function. That's fine. I'm going to clear that one out and do my new function. Parentheses 2x parentheses squared plus 1. And then push graph. See if it looks right. Did it get bumped up and did it get squished from the sides? If it looks right, go to your table, start plotting some points. Don't do that. There's no undo button on the calculators. Control Z is my saving grace on the desktop. All right, graph. So yeah, it went up. It got a little skinny. Okay. So now second table, let's plot some points. So it looks like what? 0, 1, 1, 5 are the only ones that are going to fit. 0, 1, 1, 5, and negative 1, 5. Like this. All right. How are we feeling with the calculator? Are we okay? Okay. We're going to keep using it. Questions about either one of those? Okay. If I give you the graph, can you tell me what transformation happened? So example 3, I feel like we already did this, honestly, last chapter, but they brought it up again. How did the black function become the blue function? How did it move? What is it? 3 to the left. So g of x equals f of x plus 3. I do have the function of f. It's not asking me to do anything with it yet. We will. Baby steps. Okay, one more with a graph. Okay. In example 4, they give me the starting function, which is not x squared anymore. Now my starting function is negative 2x squared plus x. And then it gave me a transformation function, which I can still use to graph what's going to happen in the calculator. We're just going to use it differently. Okay, we're actually going to graph a transformation function. So first things first, let's graph where we're starting. So negative 2x squared plus x. Let's get that in our calculators, get some points, and plot them. So back to y equals. I don't have x squared anymore. I don't have this guy anymore. Okay, so we are starting with negative 2x squared and then plus x. That's where we're starting. Okay. What's up? No. Nope. All right, I'm going to graph it and look at it. So it's reflecting down. My vertex isn't really at the origin anymore, is it? It's like slightly been shifted over a little bit. Okay. So again, let's find points. So second table. So I'm going to, so my graph doesn't go to 10. Okay, so I'm going to do -1, -3. Let's plot that one. -1, -3. All right, 0, 0. What else we got? 1, -1. 2, -6. I don't think that fits. It's like down here. Okay. Are any of those my vertex? They are not. Okay. This is how I know. Do any of those points like reflect and repeat on each side? No, they're not doing that. So none of these are my vertex. Okay. It does, if you can see, it goes up a tad after the origin. It goes up above the x-axis just a little bit. So my vertex is up here. Boop, somewhere over there. We'll find our exact vertex tomorrow, but today we're just sketching. All right, so this is where we're starting. This is our first function. Okay. So now I want you to describe the transformation. So if I have f of 0.5x and then plus 1, what does the 0.5 tell us? It's being multiplied to my x. So look at the front of your notes. We have an a value inside with my x that is less than 1. A horizontal stretch. By a factor of what?
2.
By 2, good, because it's 1 over 0.5, which is 2. So if you're not sure where we just got that, we went to the front of our paper. We noticed right here, multiplying inside my parentheses, right? The a was a 2, so we're looking at these guys. I mean, the a was not a 2. A was a 0.5. 0.5. There we go. So factor of 1 over 0.5, that's where 2 came from. 1 divided by 0.5 equals 2. So it's being stretched sideways. It's going to get wider. What else is happening? And it's going up 1. Okay, so how on earth are we going to graph this new function? Okay, we are going to use a calculator. But what are we going to type in? I'm going to replace all the x's with 0.5x, right? See how 0.5x is together? So instead of -2x squared, it's going to be -2.5x squared. Not plus x anymore. Now it's plus 0.5x. And to do up 1, we're just going to add 1 on the outside. So at this point, I'm not going to make you multiply and distribute and combine like terms. We can graph that exactly as it looks. Did I lose anybody with what I just did? Okay, so instead of f of x, it is now f of 0.5x. Okay, so all of your x's got replaced with 0.5x. What's up?
What exactly does the
Plus x. So this one's actually in standard form. This is showing ax squared plus bx plus c. So that's showing standard form. We're going to get into vertex and standard form tomorrow, like the difference between the two. All right, let's graph it. All right, so -2 It's not an x anymore. It's 0.5x squared plus, not x anymore, 0.5x. And then there was a plus 1 on the end. So we're expecting it to move up and get wider. Did that happen? Yeah, it did. It got bumped up and now it's wider. Show this to you one more time. Do we need this again?
Oh.
You figure it out? So look, what? Hold on. Do second, insert the INS, and then your decimal. Instead of like doing the whole thing. And then you push grab. We good? Oh, it's any of them. It doesn't matter. No. Mine's color, so I'm picking colors. I picked black for where it started and blue for where it's going. It doesn't matter. You could wherever you want it. It's not going to change where it shows up on the back. All right, so here's our graph. Let's plot some points. Let's go to my table. So we got some good ones. -3, -5. Then I have, what is that? -2, -2. I have -1, 0. Excuse me. I have 0, 1, and 1, 1. So I know the vertex is in between there somewhere, right? And then my other side, 2, 0, 3, -2. And then I believe it was 4, -5. Boop, something like that. Or it was 3, -5. What is it? No, I was right. 4, -5. There we go. That's our transformation. All right, any questions about graphing and using the graphing part of our calculator? Because our next two are not graphs, they're just the functions. But we'll bring the calculator back for our word problem. We okay? Thomas, we're good? Because you're following me every step of the way, right? It's going to really be not fun when you're already behind on the first section of the new chapter. Everything builds off of this first section. Everything.
What about the last one?
The last what?
Like the last half we just did?
Everything builds on each other. But this is like the launch of a new chapter, right? Everything is from this. So I wouldn't make the choice to not pay attention, is all I'm saying. All right. Let graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph f of x equals x squared. Write a rule and identify the vertex. Okay. Our parent function is what? Or my first function is what? Dang it. Our first function is the parent function. I gave away my own question. That's where we're starting. From there, it's going to be a stretch of 2, a reflection across the x, and then going 3 up. So how do I show that in a function? A reflection is going to be the negative, right, on the outside. A vertical stretch by a factor of 2 is multiplying by a 2 on the outside, right? And then translation of 3 units up, we're going to do a plus 3 on the end. Did I lose anybody? I lost some people. A vertical stretch means I multiply my function by 2, right? A reflection means I multiply my function by a negative. 3 units up means I take my function and I add 3 to it. So that's each individual one. I got to put it all together. So I'm multiplying the outside by a negative 2. That's where that came from. And then we're adding 3 on the end. Does that help? Okay. Okay, kids, what is my function? X squared. So let's change f of x to x squared. So negative 2, x squared plus 3. So that is the transformation function. Next, it wants to know, where did my vertex go? What's up?
Are there parentheses?
There can be, but it wouldn't matter. If you have negative 2 parentheses x squared plus 3, that's the same thing. That would be okay. Yep. Where did my vertex go? Where did it start? My parent function, where is my vertex? Oh, come on, kids. In your parent function, in just x squared, where is the vertex? On the origin, 0, 0. Okay? So where did the vertex move after all that? Where'd it go? It went 3 up. So what is my new vertex? Oh, it's supposed to be 3 down. That's probably why y'all are confused. It definitely says 3 down. Boop. There we go. So our vertex got moved down 3. So our new vertex is at 0, negative 3. Yes, no, maybe? Okay, y'all are quiet. Is it a lot to process? Brains are moving? Okay. You could use calculator to check if you wanted to. You don't have to with this one, but you could plug it in and see what happened to it. All right, this one. Let the graph of G be a translation 3 units to the right and 2 units up, followed by a reflection across the y-axis of the graph f of x equals x squared minus 5x. Write the rule for G. Okay. Ready? Let's deal with the whole up, down, left, right stuff first. Okay. So to go 3 units right, we're going to subtract 3, correct? And then to go up 2, we're going to add 2 to the end of my function. Questions on what I just did? Okay, yes. That just means my function. In my original function, I'm doing x minus 3 and plus 2. Yes, but now I'm going to apply it to the actual function, so you're correct. So in my function, x squared minus 5x, all of my x's get changed to what? X minus 3. You with me? So I don't have x anymore. I have x minus 3. So when I see x squared, now that's x minus 3 squared. Instead of 5 times x, now it's 5 times x minus 3. So we're not f of x anymore. We're f of x minus 3. So my x's get replaced with x minus 3. And then we're adding 2 to the end of my function. Who did I lose? Okay. So see how my original function is written f of x. This thing's in my way. Move. There we go. See how my original function is written f of x? Now it's written f of negative 3. So that shows that my x's got replaced with an x minus 3. If that was f of 4, you would take all your x's and plug in 4 for them, right? So it's the same concept. We're just evaluating with x minus 3 instead. Okay? And then we're just going to add 2 onto the end of it. So now I'm going to make you expand. Go back to algebra 1. Binomial squared, x minus 3 squared is x minus 3, x minus 3. Yeah, good old-fashioned foiling. That gives me x squared minus 6x plus 9. Yes, no, maybe. We're okay. And then this guy becomes negative 5x plus 15 plus 2. So a lot of distribution just happened. X times negative 3, negative 3 times x, negative 3 times negative 3. And then over here I did negative 5 times x and negative 5 times negative 3. And then now we're going to do a lot of combining like terms. What's up?
I'm confused on how you got to x minus 3 squared minus 5x.
I replaced the x with x minus 3. My original function was x squared. So now it's x minus 3 squared. And then it was minus 5x. So now, because of the transformation, it's negative 5 times x minus 3. Yeah? Okay. X squared is standing there by itself. Negative 6 and negative 5x gives me negative 11x. And then 9 plus 15 is 24, plus 2 is 26. All of that to not be done. That was just the right and the up. Right? Now we have to do our reflect. But it's okay. We did the hard part. To reflect across the y is to do what in my function? Make what negative? Just my x. Okay? So to reflect across the y, we just make our x's negative. So I'm going to say negative x squared minus 11 times negative x plus 26. So this is showing reflection across the y-axis. Negative x squared in parentheses becomes a positive x squared. Negative 11 times negative x gives me positive 11x. And then I still have plus 26. And that's our final function after all the transformations. So x squared minus 5x, that original parabola, being shifted to the right 3 and up 2 and reflected across the y-axis gives me a new function of x squared plus 11x plus 26. What's up? Nope, because the negative goes with my x. So it gets attached to it with parentheses. Right. If it was multiplying the whole function by it, like the negative was on the outside of my function, then it would be outside of parentheses. But it's in there. Yeah? Having fun? Do you want to bring the calculators back? Yeah, we're going to use it for our next one. I'm going to show you some more fun stuff we can do with it. Okay. Here we go. Real life situation. The height in feet of a water spraying from a fire hose can be modeled by h of x equals negative 0.03 x squared plus x plus 25, where x is the horizontal distance in feet from the fire truck. The crew raises the aerial ladder so that the water hits the ground 10 feet farther from the truck. Write a function that models the new path of the water. Okay? We're going to use our calculator. So bring this baby back. Let's go to y equals, clear this out. We have a new problem. Okay. I'll make it blue because it's water. So here we go. Negative 0.03. I'm doing my original. X squared plus x plus 25. We good? Okay, graph. Oh no, I can't see it. Okay. With real world stuff, it's not always going to be nice in a 10 by 10. We need to zoom out. So this is a feature I need to show you. Push zoom. Do you see the zoom out option? So go to zoom out. Push enter. And push enter one more time. What did it do? Oh, okay. All right, so I still don't see all of it though, do I? I would like to have more X's on my graph, right? Yes? So I need to change my window. Look up here. There's a window button. Right? Because I like the height of it. I just need more X's. So I'm going to go to my X max. All right, now it's stopping at 40. I need more. Where do you want to go to? I mean, you could. Do you want to go to 100? We clearly need more than 41. It wasn't barely off the page. I need a good chunk. What do you want to do? 80? Sounds great. And you can always like put something in, look at your graph, and if you don't like it, you can go back and change it. So like if you did 100, but that was like, well, that was too much, you can always go back and do smaller. Okay, I can see the whole thing now. What do you mean? Go back to your window? Push window again. Okay, so here's the graph. Cool. What do I need to know about this graph? I need to know where the water is hitting the ground. Right? On the other side. So like where it's hitting the x-intercept. Yes? No? Maybe? Okay. So the table's not going to help me because we know that that's more than 40. I'm not going to be scrolling down on my table forever and ever. We can tell it to tell me the exact x-intercept by calculating it. So second, calculate. This is called a 0 because it's when your y equals 0. So I want to find the 0 of this graph. Push enter. There's more than one, so we have to tell it which one we want. So move your arrow over. Whoop, too far. There we go. See how my bottom, it says left bound right here? So go just to the left of your x-intercept, so a little bit above, and push enter. It will make a marker. And then it says right bound, so you're going to go over to the right on the other side of your x-intercept. Push enter again, and it makes another marker. So when you make your two marks, make sure your x-intercept is in between them. And then you push enter, and it should tell you that the 0 is 50, 0. Yes. How do you get to what? So second, trace. See how the calc is in blue letters? So do that and then do 0. You're finding the 0 of the function, which is your x-intercept. Okay? So how far is the water being sprayed right now? If it's at 50, 0. It's being sprayed 50 feet away. Okay? So right now, I'm just going to do a little picture. Woo. Right now, it's hitting at 50 feet. Okay? It wants to raise the ladder so that way that's happening 10 feet farther. So where does it want it to be? It wants it to be at 60 feet. Okay? So I need to raise it up. So using my calculator, Where are we at with 60 right now? That's a specific value for x that I want, right? So we can find it. Go back to calculate. We like calculate. I can find the specific x value. Push enter. I want the value of when x is 60. Last time I didn't know x, so that's why we did the 0. This time I know what x I'm looking for. I'm looking for when x is 60. Where is y right now? Negative 23. So how far are they going to have to raise the ladder?
23 feet.
We're going to need to raise the ladder 23 feet. Okay, so right now this is at negative 23. So we need to go up 23. So with my function, we just have to do what? Just add 23 to the end. Plus x plus 48. That's the function, the new function of now the water coming out of the hose if it gets lifted up 23 feet. And now the water's being sprayed 10 feet away. I know that was a lot. You're doing great. Just let it soak. No homework.